Question 1. This is a very straightforward question. It has some data given, and then they're asking us to find the value of sigma t minus 120. T is the data itself. So basically they're saying that first subtract 120 from each data and then add it. So let's do that one by one. I will do it mentally. You can use calculator for this. So 95 minus 120 will be minus 25 plus 126 minus 120 is just 6 plus 117 minus 120 is minus 3. 135 minus 120 is 15. 120 minus 120 will be 0. 125 minus 120 will be 5. 114 minus 120 will be minus 6. 119 minus 120 minus 1. And 136 minus 120 will be 16. And this is equal to sigma t minus 120. And now I can do it myself, and you can use calculators. So minus 25 plus 6 minus 19 minus 22 minus 7 minus 2 minus 8 minus 9 plus 7. Answer is plus 7. Similarly, we have to find sigma t minus 120 squared. Every number here will be squared now. First subtract 120 from each data, square it, and then add it. So I'll square them one by one. So 25 minus 25 square will be 625. 6 square will be 36. Minus 3 square will be 9. 15 square is 225. Plus 0, I'm not writing it. 5 square is 25. Minus 6 square will be 36. Minus 1 square will be 1. And 16 square will be 256. And we can use our calculator to add all of them. And that will be sigma t minus 120 square. And that will be 1213. Done. Let's move on to the second part. Okay, using your values in part 1, calculate the variance of t. So the formula for variance is sigma t minus 120 square over n minus mean, which is sigma t minus 120 over n square. N is the number of data we have, so they are how many? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. They are 9. So we have the values of both of them, so we'll use 12, 13 and 7. So this is 12, 13, we just got it. So equal to 12, 13 over 9 minus, we got sigma t minus 120 as 7 over 9 square. This is not squared, okay? It was part of the equation already, so we didn't write it. So this, if we put in our calculator, it will be 134.2, and we can ignore 1.2 because 3 significant figures are 134. That's the answer. Jamil has 5 plums. Okay, Jamil, he has 5 plums and 3 apricots, and there is Rosa, she has X plums and 6 apricots. Okay, one fruit is chosen at random from Jamil's box, so it's not specified whether that is plum or apricot, so one is selected from 8 fruits he has. Similarly, one fruit is chosen at random from Rosa's box. Rosa has total X plus 6. C, one is chosen from her box. The probability that both fruits chosen are plums is 1/4. So basically it will be the probability of a plum and a plum. Plum in Jamil's box and plum from Rosa's box, okay, is 1/4. Write down the equation in terms of x and find x. All right. So let's talk about, because there's and, it will become probability of plum from Jamil's box multiplied by probability of plum from Rosa's box is 1/4. So let's interpret them in Jamil's box first. And we can find it straightforwardly. There are total 8 fruits. We are selecting. The probability of plums is 5 out of 8. Right? We could have written 5C1 over 8C1 also. But let's not complicate it. We can straight away write this. Alright. Multiplied by x out of total x plus 6 equal to 1/4. So it becomes 5x over 8x plus 48 equal to 1/4. So let's complete it here. So cross multiply, 4 times 5x will be 20x equal to 8x plus 48 cross multiplied. So 8x goes to the other side. 20x minus 8x equal to 48. 12x equal to 48, and x becomes 48 over 12, which is 4 plums. So Rosa has 4 plums. Question 3. A fair 6-sided die is thrown twice. Okay, it's a fair die. That means the probability of each number of the 6 numbers is equal. It is thrown twice, okay, and the scores are noted. Even x is defined as the total of the two scores is 4. Alright, so we need to make a table for this because both of them are combined. So let me make a table, it will help us in answering this one. So 1, 2, 3, 4, 5 and 6. This is the first die. Let me make the one for the second also. So 1, 2, 3, 4, 5, 6. Okay, so I have written one in a column and one in a row, and their combination will be in these particular cells I'm getting out of the table. Alright, so the total number of two scores is 4. So 1 plus 3, here it will be 4, 2 plus 2 will be 4, and 1 and 3, these will be 4. So total, you can see there are 36 cells, total 36 cells, and probability that total is 4. Total means the sum of the two outcomes is 4, is 3 out of 36. That's the probability, which can be simplified to 1 over 12. Alright, event y. So we can write this one as P of x. Second is probability of y. Is defined as that the first score is 2 or 5. Let me change the colors and I will mark them by crosses. Alright. The first scores are 2 or 5. This one is first. This one. So we'll look at this is the one. This is 1 when first is 2. What is second is not important. This is 5. The first outcome is 5. Second outcome is not important. So we are selecting all of them because second of them are not important. So total they are 12. I can see 6 and 6, 12. So it will be 12 out of 36. And if we simplify, it will become 1 over 3. Alright, done. Are events x and y independent? Justify your answer. So you must know that the two events are independent if x intersection y is same as probability of x multiplied by probability of y. So
converse of this is also true. If the multiplication of 2 is equal to probability of x and y, intersection also means and, okay, both of them are happening, okay, probability of x and y, then the event is independent. Did you get the idea? If this relationship is correct, events are independent. If events are independent, this relationship is correct. All right. So we are going for the opposite one. When this is proven that this relationship is correct, our events are independent. If this relationship is not correct, our events will not be independent. All right. So we already know px, we already know py. The only problem is we have to find px and y, or x intersection y. Out of these 36, what are those cells that represent that the first uh, outcome is 2 or 5 and the sum is 4? Sum cannot be 4 when the first outcome is 5. So this whole column is useless for us. Okay. It is possible to have a sum of 4 when the first outcome is 2, and this is the only cell where it is happening when both of them are there. So only one cell out of 36 is representing px intersection y, and we had px as 1 over 12, py as 1 over 3, and we can see that this statement is true. 1 over 36 is equal to 1 over 12 times 1 over 3. That means the events x and y are independent. That's the final answer. Let's move on to question number 4. The mathematics and English A-level marks of 1400 people all taking the same examinations are shown below. Okay, the cumulative frequency graph is given here. Both are out of 100. Okay, use suitable data. Okay, they're asking us to use some data for these graphs to compare the central tendency. So when we say central tendency, we can use mean, mode, or median. From cumulative frequency graph, median is the one which we can find easily. It is not easy or accurate. So it's better to use median for them. And then they're saying find spread of marks also. For spread, we can find lower quartile Q1 or upper quartile Q3. And then we can find IQ or also interquartile range. That will give us spread of marks, and then we can make some statement as a result. All right, so let's find the median first through this particular graph. So median is, if total students are 1400, right? 1400, so we divide that by 2, which is 700. At 700th position, we'll get a median. Where is 700? Here is 700. So let's find median for both. So this is for mathematics, and here this is for English. So for mathematics, the median will be, let's go down, exactly at 40. All right. Now for English, we'll go down like this. So if this is 50, 52, 54, 56, 58, 60. Okay, so this is 56. So English median is 56. Okay, so that shows that the average score in English is higher than mathematics. All right, let's go to Q1, lower quartile. For lower quartile, we'll divide 1400 by 1/4, we'll multiply it with, so that will be 350. Okay, so 350 will be 1, 2, 3, 4, 5, so 2.5, right? 1, 2 and half. Here, This is where we'll find Q1 for mathematics, and this is where we will find Q1 for English. Okay, so for mathematics, it will be at this place, which is 12. Okay, so mathematics Q1 is 12. For English, Q1 will be, let's go down, 42. Okay, very high as compared to mathematics. We can already see that mathematics exam was harder, so they scored lower, and in English they scored higher. Third thing, Q3, okay, upper quartile. For Q3, we will write 3/4 of 1400, which will be 1050. So we'll look at the 1050 in frequency, cumulative frequency axis. 1050 will be here. So we can go here for English and here for mathematics. I have marked it up, down. Okay, so this line is reaching at 62. So for English, Q3 is 62. Okay, what about mathematics? There's a dark line which will be at 80. Yeah, 80. So the Q3 for mathematics is 80. And now we can find IQR for math will be 80 minus 12. Q3 minus Q1 gives us interquartile range, which is 68. All right, IQR for English equal to 62 minus 50, no, 42. 62 minus 42, which is 20. Now we have to make statements. So we can see that here the range is quite high, interquartile range. Here interquartile range is very, very close. That means mathematics scores are more spread out than English. On average, students scored better in English. These are the statements based on data. They did not ask us to draw anything, just analyzing the data. This is our conclusion. All right, let's move on to the next question, number 5. In a certain country, the probability that a child owns a bicycle is 0.65. Oh, quite high. A random sample of 15 children from this country is chosen. Find the probability that more than 12 own a bicycle. All right. So we can see clearly that we have been given a probability of success that child owns a bicycle. So probability of success P is 0.65. That means failure will be 1 minus 0.65, which is 0.35. Every child is independent, so every event is independent. The probability is remaining constant throughout, and we have fixed number of selections, 15. So all 4 conditions for using binomial probability distribution are there. So we can use binomial distribution clearly. Probability that X is greater than 12, right? More than 12 own a bicycle. So it should be more than 12. Can also be written as probability of X is equal to 13 because it's more than 13, more than 12. 12 is not included. Or probability of x equal to 14 or x is equal to 15, right? We can't have more than 15. And we'll use binomial probability for all of three. So let's start with x equal to 13. So it will be 15 C 13 because we want 13 successes. So 13 out of 15. The number of successes are given their probability 13, and the failures will get rest of the 2. 13 plus 2 is 15. Here it will be done. And now we can just place all of them into calculator and we can get our answers. By the time I calculate them with my calculator, please subscribe to my channel so that I give you more solutions, detailed solutions of such exams in future. And in comments, you can demand if you want a solution of specific questions from IGCSE, A level or AS level, any year, any question. I will make videos on that. I will answer to your comments and I'll make videos on that. Using my calculators for this, I got 0.0617. That's the probability. It is parts 2. A random sample of 250 children from this country is chosen. Okay, now the number have increased to 250 from 15. Use a suitable approximation. Yes, it's a very big number, so we have to use approximation to find the probability that fewer than 179 own a bicycle. All right. Since the number is too big, we can't use binomial distribution anymore. So normal distribution could be one solution. So let's test for using normal distribution. NP should be greater than 5 and NQ should also be greater than 5. And that's what we should test before using that approximation. So N is 250, P was 0.65. So that will be how much? 5, 12, 150, 162. So 16.25. Oh, sorry, it is 250. So it will be 162.5, which is quite high. So remaining 250 times 0.35 will be how much? 50 and 37, 70, 87.5. Okay, so both of them are much more than 5. So yes, we can use normal approximation for this. Okay, so the mean is NP, which is 162.5, and we want standard deviation as well. So it will be standard deviation will be square root of NPQ. So it will be NP is already with us, 162.5 times Q is 0.35, 7.541. So I will use 7.54 as standard deviation. Okay, the situation is they want the probability of fewer than 179, probability that X is less than 179. Okay, so let's try to draw the situation first. This is normal distribution curve. The mean is 162.5. Standard deviation is 7.54. 179 will definitely be above this here. Since they want less than 179 and it's a discrete data, number of children are discrete, we can have 178 less than this. So in place of X, we will not use 179, we will use 178.5 so that we get less than 178.5. And what is less than 178.5? 178. That's what we want. So this is a key idea. Please never use the one which is a complete number. Try to come closer to the number you want. And that's why I have come closer to 178 by using 178.5. So I need to use Z score first. So let's find Z score, which is the X value minus mean divided by standard deviation. So here it is 178.5x for us, 162.5 is the mean, and 7.54 is the standard deviation, and we'll find z score now for this. So I got z score as 2.122. I think we'll need 3 digits. Yeah. Okay. So let's use our table for this. 2.122. 2.1 is 0.9821 here. 2 will be 0.9830, right? And 2 after that is 1. So it will be 0.9831. 0.9831. Okay. So probability that x is less than 178.5 is 0.9831. And since in A level or AS level we want 3 significant figures as answers, we can round it off to 0.983. That will be the final answer. Question 6. It's a long detailed question. I would recommend that you pause the video and read up to here and try to understand what, rather you can up to here you can read and try to understand the details of the question, and then we'll proceed with the question. Okay, I hope you have read the question and its details. Now we will answer the first one. Show that the probability that Amy loses her original $1 is 0.64. This is the case. This third case is the one when she loses her original $1. That means probability of that Amy does not ring the bell and she again doesn't ring the bell twice. So probability that she does not ring the bell first multiplied by probability she does not ring the bell again. She fails to ring the bell both the times, and the chances of her ringing the bell is 0.2 every time independently. So that means probability of ringing is 0.2. So probability of not ringing the bell will be 1 minus 0.2, which is 0.8. So we'll write here 0.8 multiplied by 0.8, that is 0.64, and this is what they wanted us to show. Let's move on to the second part. Complete the probability distribution table for the amount Amy gains. Okay, so gains, since they are talking about gaining, here she's not gaining anything, it is losing 1, so it will be minus 1, right? Then if she gets the first attempt correct, she will gain $2. Yes or no? But when she gets the bell ringing at the second attempt, she gains $0.5. Okay, so let's find the probability that she rings the bell in her first attempt, and that means she's successful in the first attempt itself, and we know it has been given as 0.2. Now we can find the third one because we know the probability of sum of all the probabilities is 1. So 0.64 plus 0.2 is 0.84. So 1 minus 0.84 will be 0.16. Definitely this is going to be 0.16. But still, let's challenge us by calculating 0.16. She fails in first attempt, right? So failing is 0.8. In second attempt, she is successful according to this one, which is 0.2. And if I multiply both of them, it is 0.16, and that's correct. Total is 1. 0.16 is the third one. And complete the probability distribution table for the amount that she gains is 4 marks worth. I have done it mostly by explaining you. You can write everything here in this space. Now, third part. And here it is. We have to find Amy's expected gain. Our variable is Amy's gain, so let's call it x. So they are asking us to find expected value of x, which is sigma x multiplied by probability of x. So x is this, probability of x is this. So we will just multiply each x with its probability and add them up. That's what sigma means. So this is what it is. So minus 1 multiplied by its own probability is 0.64 plus 2, it's a gain of 2, probability is 0.2 plus gain is 0.5 and its probability is 0.16, and we can do it here. Minus 0.64 plus 0.4 plus 0.08, and it will be 0.48 and 0.64. She will have a loss of 0.16 cent. It is expected that she will have a loss of 16 cents. Weight of an adult female giraffe has a normal distribution with a mean of 830 kg and standard deviation equal to 120 kg. Okay, there are 430 adult giraffes in a particular game reserve. Okay, so n is 430. Find the number of these adult female giraffes which can be expected to weigh less than 700 kg. Okay, so they want expected value to be less than 700 kg. Now we know that the expected value is equal to NP, number of sample multiplied by the probability of the criteria. So n we already have, probability we don't have. So we will use normal distribution to find the probability that a giraffe has less than 700 kgs weight. So let's draw the situation on normal distribution graph first. Always I recommend please draw it so visually we can find how to go about it. So the mean is 830 kg here. Standard deviation is given 120 kg and they want less than 700. 700 will be much less than 830. So let's say 700 is here. We want the sum of probabilities in this area, basically the area under curve less than 700. Okay. So to find the probability first, we should have a z-score which is equal to x minus mean over standard deviation. X in this case will be 700 because we are trying to find less than 700, right? So 700 minus 830 over standard deviation is 120 kg. Now, in one of the cases, one of the questions before this, we added 0.5. That was discrete data. This is continuous data. 700 kg is a continuous data. That's why we don't have to add or subtract anything. 700 remains 700 in this case. So, in this case, it will become minus 130 divided by 120, which is minus 1.083 almost. All right. So whenever z is a negative number, we should do this. Convert this negative to positive, and probability of x less than 700 in this case, yeah, will be 1 minus probability of z equal to positive 1.083. Make it positive and subtract from 1. That's how we get this. Let me tell you what is the logic behind it. We reflect this particular, we know that normal distribution curve is very uniform, accurate on both sides. So what we do, we reflect it on the other side, right? So that we get this area. Let me change the color of that area I'm talking about. This area we'll get, right? And subtracting from 1 will give us this area, which is exactly reflection of the area we want. And that's why we do. Whenever you have a negative z-score, just do this. 1 minus probability of the positive z, same positive z-score. So let's try to find out what is the probability when z is 1.083. Here it is. 1.083, it will be 1.0 is here. 8 will be here, 0.8599, 0.8599, and 3 will be 7. So plus 7, the last digit, it will become 0.8606. 0.8606 is the probability when z is positive 1.083. 0.8606, and now we can subtract and we'll get what we want, 0.1394. This is the probability we wanted to find the expected value here, this p. The probability that the weight of giraffe, female giraffe, is less than 700 kg. So expected value of x equal to 700, right, will be 430 are the total number of giraffes, right? Let me confirm. Yeah, 430 was the number, multiplied by 0.1394. Okay, we got the probability. This is n, this is p, and I'll calculate it with my calculator. By the time I do that, please subscribe to this channel and motivate me to make more videos for you in future also. And if you have any question from IGCSE or A and AS level of Cambridge International, you can let me know in comments and I'll try to make videos on those questions. Okay, so the answer I got was for 59.94, because the number of giraffes cannot be in decimals, so we'll write it 60 giraffes. Part 2 of the same question. Given that 90% of adult females weigh between 830 minus W and 830 plus W, and 830, as far as I remember, is the mean. Yeah. So let's draw this situation. 830 minus W. This is 830. So minus W will be somewhere here. This one is 830 minus W, and same W will be here. This is 830 plus W, and the probability that the weight of giraffes is between these two is this area, and total probability is 0.9 because there's a 90%. Find the value of W. What is this W? How much more or less than 830 is this? So let's focus on only one. Okay, let's focus on the positive part, right? This one, positive, because we have Z scores for positive. So will you agree that if I take only area from here to here, not this, only this area, if the whole is 0.9, half of that will be 0.45, isn't it? This will be the probability from mean 830 and 830 plus W. Let me redraw a new situation which we have just discussed. This is 830. This is 830 plus W, right? So if I find probability that X is less than 830 plus W, that means we are talking about this area, right? If I subtract probability of X is less than 830, which is this one, this area. If I subtract this area from that previous one, I'll be left with what I want, 0.45, this remaining area. This will be left out. And we know probability of X is less than 830 is 50, 0.5, isn't it? That means we have to have this F probability X less than 830 plus W minus 0.5 equal to 0.45, which we just found out. Okay, what this means is that probability of x less than 830 plus w will be 0.45 plus 0.5, which is 0.95. Let's go, where is 0.95 probability there? 0.95, this is 0.9495. If you look here, 0.9495, I want 5 more. This is 5 more. That will make it 95%. So it becomes 1.64 and 5. Okay, 1.645 Z score. So let's continue it down here. So Z score we just got 1.645 is some value x minus mean. Mean in this case is 830 kg divided by the standard deviation 120. Let's cross multiply this and we should get x through that one. 1.645 multiplied by 120 is equal to 197.4. 197.4 equal to x minus 830. 197.4 plus 830 equal to x. So can I write this as w now? W plus 830 equal to x. And when we started look at the question, it was 830 plus w. This is what we wanted to find out, 830 plus w. So we got the value of w now. It is 197.4, which can be rounded off to 3 significant figures, 197 kg. Okay, next part of this question is this. The weight of adult male giraffe this time has a normal distribution with the mean 1190. So let me try to visualize this again. 1190 is the mean and standard deviation is, okay, sigma. All right, this is standard deviation. Given that the 83.4% of adult male giraffes weigh more than 950 kg. So 950 kg will be less than this, 950. And this is 0.834. 83.4% can be written like this. Okay. That means this probability will be 1 minus 0.834, which is 0.166. This one. Right? Since we are sure that there will be a negative Z score because of 950 being less than 1190, let's reflect this area here, which will be 0.166. But in Z score table, we have lesser area, which will be 1 minus 0.166, and we'll get back 0.834. So let's find 0.834. What is the Z score related to 0.834? Okay, so 0.834 will be 834. Can you see here? 0.834 is here. 0.97. 0.97 is the Z score. Okay. So 90. What is this? 950 minus 1190 over sigma, we don't know, but now we know that the Z score is 0.97, but it has to be a negative Z score because we know it is less than 50%. It is on the left side of the mean. So now we can do the normal calculations. So we can interchange their places. So 950 minus 1190 will be minus 240 over minus 0.97 equal to sigma, and 240 divided by 0.97 will be 247.42. 247.42. 3 significant figures, it will be 247. Here Freddy has 6 toy cars and 3 toy buses. So 6 cars plus 3 buses equal to 9 toys. Okay. All different. This is important. They are different means if they are identical, it is difficult to distinguish between them, but they are different. That means they are totally different from each other and we can count them separate. He chooses 4 toys to take on holidays with him. In how many different ways can Freddy do that? Okay, choose 4 toys. Okay, all of them, right? So he has to choose 4 toys from total 9 toys. So 9C4 will be the total number of selections, which is 126. Okay, second part, how many of these choices will include both his favorite car and favorite bus? That means he has a favorite car and a favorite bus. That means total 2 are already among the selected ones. Remaining 2 are to be selected from the remaining toys. There are total 9 toys. So out of 7 toys, he has to select the 2 toys because other 2 places have been taken care of by his favorite cars and bus. So 7C2 will be 7C2, 21 selections are possible. Okay, so let's go to the next one. Freddy arranges these 9 toys in a line. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Find the number of possible arrangements if the buses are all next to each other buses. So how many buses were there? 3 buses. So let's make a box around the 3 buses. B, B, B. And they are not identical, keep in mind. So B1, B2, B3, that's what we should distinguish them. Because they can also change their places, right? So now we keep them together and move them together in this box. So how many places are there now? 1, 2, 3, 4, 5, 6, 7. So 7 factorial ways these 7 objects can be rearranged because the places are 7 and candidates are 7 and these are counted as 1. Multiplied by these 3 can change their places within the box. So we have to write 3 factorial here as well. And that will be the total number of arrangements possible, which is 30,240. Okay, the last part. Find the number of possible arrangements if there is a car at each end of the line and no bus are next to each other. So 2, 3, 4, 5, 6, 7, 8, 9. One car is here, one car is here. C1 and we don't know which one. Okay, so they can interchange their places. So first we have to select these 2 cars out of 6 cars. A car is here or here, it's a different arrangement. So it will be 6P2. 2 cars selected from 6 and they are arranged also certain places. So this takes care of the ones at the corners. Now the problem is with these remaining 7 places. Okay, in those remaining 7 places, no buses are next to each other. So remove buses. There are 3 buses. Remove them. Okay, so we are having now 4 cars, remaining cars. Just concentrate on these 4 cars, and these 4 cars can be rearranged with each other, right? So 4 factorial. Now remaining buses can take place this here, this or this. There are 5 places available for the remaining 3 buses and they can be arranged as 5P3. Why? Because if the bus takes this place and this place, there will be no bus here and here, and that's the new arrangement. These spaces will be empty, and this is how we ensure the buses are not together because there will be something between them all the time. So this will be the one we would like to have, and let's see what number it gives us. It gives us 43,200 arrangements.